data is such a bespoke art. No two companies do data the same. Everybody's assembling out of the cloth that they find in different places. No two stacks look alike. It's kind of nuts. If I can make you 10x more productive with your data, maybe you'll do it. That's my hope.
Welcome to Data Talks on the Rocks. I'm Mike Driscoll. Back in 2012, Lloyd Tabb incorporated Looker with a simple thesis. Cloud data warehouses would change everything. When Redshift and Snowflake launched, to great fanfare, Lloyd thought, we win. 13 years and a multi-billion-dollar Google acquisition later, he's building again. But this time, the bet is different. I sat down with Lloyd to discuss why he spent nearly 2 decades chasing the same vision, why the semantic layer is harder than anyone admits, and how Malloy is disrupting SQL, the very foundation that made Looker so successful. We get into graphs versus rectangles, mighty DuckDB outrunning massive Redshift clusters, and whether the data world is finally ready to move beyond SQL. Let's get started.
So LiveOps was this amazing company that was the first gig economy, one of the very first gig economy companies. I was at Netscape, and I was one of the founders of Mozilla.org, and we met this company called this team called Nuhu, which was trying to write was building a crowdsource to replace the Yahoo directory. I don't know if you remember the Yahoo directory, but it was human edited, and they had engaged 50,000 people to work on this directory, and I got very excited about that. And so we brought them into Mozilla.org. We renamed it the Open Directory. And I ended up working with those guys, and I just saw the power of putting people to work on the internet. And after Netscape, I worked in middle school for a while, and did some philanthropic work. And then a friend of mine was talking about a company that he was working on. He was doing basically a Twilio company, and he met a company in Florida that was doing a home-based telephone operator thing, right? Anyway, LiveOps ended up putting 30,000 telephone operators to work, answering phone calls on the internet. And we needed we needed tooling to be able to figure out how to manage all these people, right? So we had, are they doing well in the calls? What's the revenue like? Is this media buy working for our clients? So anyway, it's a huge data problem, and we wanted everybody in the company to be able to understand what's going on in data. So I wrote LTool, which was a LiveOps tool, so that we could so that everybody could see what was going on in the data.
And in particular, what was that tool? Was it a browser-based tool? Was it a CLI that people could use?
It was a semantic modeling language. Mm-hmm. It was actually semantic data structures that described all of the aggregate calculations and the dimensional calculations in code. It was actually written in Perl. And then it had a web-based interface so that anybody could write queries by clicking on dimensions, measures, filters, and sorting. And it automatically drilled, and so we discovered the drilling pattern, and so it was everybody in the company could actually understand what was happening in all of the call volume data, could drill in, could understand, could do the forecasting.
Can you tell me why my customer service calls always take 37 minutes to get something very simple solved?
we were doing so customer service is really hard, but orders are really easy. So we had all of our customers were 800 numbers that were selling things at the time.
I see.
And so we could judge those. And it turns out that in that case, a long call is not a bad call.
Oh, right.
Turns out it's
highly correlated to the spend.
It's not. It's actually it's not. So sometimes the short call works, but it's not correlated. It's just not correlated. It's not like it's right or wrong.
Okay.
It's just not correlated.
Uncorrelated, orthogonal.
Yeah.
Okay, and so naturally this LTool, which taught some of the patterns that I think clearly inspired later work, what was the back end for?
So we at LiveOps, it was MySQL. We worked against replicants. So we basically, the way we would architect these things is you'd have your transactional server and then a replicant, and you could get real-time answers to what was going on in the data. So it was only seconds behind, because mostly so a lot of times with reporting it's delayed, and latency means that you can't really use it. Like you can't do self-driving cars if there's high latency, right? So there are a lot of things that don't work in high latency.
You can do them very dangerously.
So latency. So it's funny. We don't often talk about latency in data with reporting, but low latency reporting is super important. especially if you're going to try to run your business by it.
Right.
And so it's relatively easy to extract data, do transforms and stuff, but building low latency reporting that is complicated is hard.
And so now let's take the next step, the next LTool that came out of this work, the actual Looker tool.
Oh, actually, there were two more after that.
Two more. Okay, so tell me about. So because they were named.
I mean, I keep writing the same thing over and over again. Okay, it's like.
So let's talk about those next two tools. They're also called LTool. One was called EL tool.
The EL tool happened at a company called Luminate.
Okay,
and we were an ad tech company, basically trying to do ad placement in Instagram-like things. Believe it or not, like take the. It was pre-influencer. We were trying to figure that market out. We didn't figure it out. Luminate eventually got acquired by Yahoo, but not for a great thing, for an acqui-hire kind of thing. But we built LTool there, and then I was working at another company that was trying to do a staffing, a crowdsourced company that didn't work at all, and but I wrote it then too. And after that one, I met my co-founder Ben Porterfield, and I said, "Hey Ben, I built this thing 3 times. I know every company that can't see their customer directly needs this tool." And so I sat down and started writing it, and Ben and I, we've roll forward, and 8 years later we were acquired by Google.
So Looker, so Ben and you started Looker in 2011.
We started in 2011. We didn't incorporate until January 2012.
Okay.
Like we actually had our first customer before we bothered to incorporate. We incorporated to take the check.
Isn't that kind of like what Larry and Sergey did? Supposedly, I thought the story is.
Yeah. No, we actually had it working at a company called PayNearMe that I basically walked up and said, "Danny, let me do your data for you." He said, "Okay."
And what were one of the biggest decisions that I remember when sort of first seeing Looker was you made a bet on cloud data warehouses or cloud databases, and of course, today that seems like a no-brainer. But tell me a little bit about that architectural choice to plug into cloud, or whether that was not the case initially, and that was an evolution.
The bet was SQL.
Okay.
So remember, at this time it's Hadoop, and it's processes writing MapReduce, and that's the way people are doing analysis, because SQL can't handle this large enough data. And we're like, no, you're wrong. It's SQL. And so we started, and we originally connected to Postgres and MySQL.
Okay.
And as soon as we saw Redshift, we said we won. that was like, oh wow, look at this! It can go 100 times faster than Postgres. Okay, we win. Was
that also like did it propel forward Looker because of that massive expansion of Redshift, and led to people looking for tools that worked?
It was relatively easy to set up. You could show value almost immediately. People were finding Redshift without us, and then not being able to manage it very well. We could come in. So the way Looker sold was we would not we would never ask for money up front. We would just say, let us hook up Looker to your data. Let us show you what your future can be like. We would go into a trial. It would take the way that our focus was on workflows. Our focus is to make the data developer as efficient as you can possibly make them, and make them the hero in the company, right? If we can make the data person successful in the organization, and actually give sight to the rest of the organization, that person's career is going to change, and they're going to pay whatever we ask for this. So Looker is notoriously expensive, right? And the reason is that because we were doing value-based pricing, we would walk into a company, we would in a couple of hours, we would set it up, connect to like whatever their main transactional table was. So like, and then to ask them what they want to know, and then being in the sales call, being able to show them answers to their own data in the sales call, and that would just turn everybody on. They would go, "Oh wow, I get it." And then we would let it run for a while, and then people would start sending URLs around with look at this and look at that and look at that, and then we would have engagement
metrics on that.
Yeah, and as soon as like we had like 5 or 6 people doing this, we would go, okay, now it's time to pay.
Right. So, you were using Looker for those metrics, of course. Okay, interesting. Now one of the challenges clearly that you ran into at Looker over time became, or many of the challenges that you ran into at Looker over time inspired this next phase.
Yeah.
Tell me a little bit about the evolution for how we got from Looker to now. Fast forward.
So Looker is designed to create a visual interface to data for, real-time transactional stuff so you can understand it, or analytical stuff. Right. And the goal here is, and it changes the relationship. So the normal relationship of data is data engineer produces a data pipeline, data analyst takes the output from the pipeline, produces reports, and the consumer looks at the reports, right? And then they have another question, and then it goes back to the analyst, and they get in line, rework the reports, and this changes that relationship. It changes it from analyst to the analyst builds the semantic model, and then can actually just send URLs to the people, and the people can explore the results, and so um, the um, but that's all visual, right? That's all in the UI. It's all about but it so data scientists didn't like Looker very much, right? Data engineers don't like Looker very much because the visual is the end state of the data, right? So you're ending up with data at the end state. It's great if you're looking for something or you're trying to do an investigation, but we haven't worked our way down the stack in terms of, like, everybody are still transforming their data with SQL, and data scientists are using SQL to do transformation. How can we address them? And so we realized that the semantic model is right, with dimensions and measures. Storing the reports in data, Looker stores its reports in database. Huge mistake. You want that in the semantic model. So we spend all this time trying to figure out how to validate that the reports, the fields that are referenced in the reports, are still in the semantic model. And when the semantic model changes, the reports break. And so we put all of the reports in the semantic model itself, in terms of views, as building blocks, right? So we now have a semantic model for the dimensions, measures, joins, the building blocks. Okay, and then we have a very simplified language for writing queries, for writing very complicated queries. And so the semantic model describes your data, and then transformation is really simple.
What's the macro trend? You talked about when Redshift came out, you thought, okay, we win. This is clearly, running MapReduce on Hadoop clusters is not the way that companies are going to make sense of their data. What do you feel is the kind of macro trend that Malloy might ride that says, okay, Malloy wins? Or what, maybe that could be a plural question too. What multiple trends do you?
So, I mean, there are things that we haven't done yet that we want to do, that I think, so we're still experimental, right? We're still early. The data is everywhere, and federating data is really hard. And every different SQL engine has very different semantics. To do anything besides a simple group by, aggregate group by, is totally like arrays. They don't even look like the same language. Arrays in every SQL dialect do not look at all like one another. Unnesting does not look at all like anything else. Right. So, the basic window functions and operations on a normal rectangle are the same, but everything else is different. And when we think that the opportunity for Malloy is to unify that in a way, they're all coming to the same conclusion because they're all building the same features. They're just all building them very differently. And so I think we have an opportunity here for Malloy to actually unify that.
What do you think about, there's an open source project out there called, I think, called SQL Glot.
I think that's a really useful tool.
And are now with Malloy supporting, all these different dialects, tell us a little bit about how you're going to, manage to talk to Snowflake and Redshift and
so
DuckDB. And
so Malloy already does this, right? So you can take a Malloy model and just change the database it references, and it will run the same code on all of them. So there's a core Malloy library that's guaranteed to execute the same on all of these dialects, and that includes the array aggregation and the nesting stuff, and the complicated features are all uniform in Malloy. But you can still access the individual database specific functions if you want. I don't think that so there are two bets. One is people. I mean, if I walk in this room, everybody will tell me that I'm crazy and that nobody's going to give up on SQL. I mean, I hear that all the time, right? Oh no, nobody wants to learn a new language. Nobody wants to. And um, so SQL is saying is that bad?
Mm-hmm.
And there are a lot of people making this bet. It's like, oh yeah, it doesn't really matter. SQL's never going away. We're just going to and SQL is the translator for that. And it's interesting.
Mm-hmm.
It's an interesting strategy. But maybe the world will move forward, right? And I'm the optimist, right? I'm the optimist. Maybe it'll move forward. Maybe if I can make you 10x more productive with your data, maybe you'll do it. That's my hope. Like if I can make you a lot more productive with your data, or not me, Spiros can make you a lot more productive with the data. That's and so there's a lot that falls out by moving forward. And I want to also say something else. I, I spell my name in lowercase, and I do that because I'm part of a team always. All right, and so this is there's the myth of the founder. Like you're like having me up here is everything that I've done in my career, I've done with a team of people, and everything that I think has not necessarily come out of my head. It's come from the team thinking about things together.
Mm-hmm.
I may just be the collector of it, but I just wanted to
call that out.
I wanted to call it out.
Well, it's certainly something that I think when we talk to people who've been at Looker, one of the things that always strikes me is the culture and the people. There's a lot of heart in the folks that I think have chosen to work with you and you've chosen to work with. So, and I think actually that in some ways, one of the things I've always loved about the data community writ large is that, not that I've been a part of a ton of different tech communities, but it does seem like the data community is always
great folks.
Yeah, really great people. It draws a certain a style of folks. Maybe it's empathy via all of that data munging we've all done.
Yeah, I have no idea why.
After writing Perl regexes for enough time, you start to have a lot of empathy for other members of your tribe.
Yeah, data is such a bespoke art. Like, no two companies do data the same. It's like everything's custom tailored to the situation. Everybody's assembling out of the cloth that they find in different places. No two stacks look alike. It's kind of nuts that we don't all wear the same. It's like everybody puts together their own data outfit, and it's wild actually.
Well, I think the for a lot of people, they think about data stacks. Right. It's like, well, one data stack should be the same as the other, but every factory is different. Right. And so working with data is not that, it probably has almost the same amount of entropy as working with atoms. And so when you're a manufacturer, whether you're making iPhones or you're making clothes, it's a very different manufacturer. So I'm going to now push a little further on Malloy and some of the bets that I see as a member of the Malloy community and as someone who's dabbled in it. One of the bets I've seen is on the other side of the continuum. You talked about Redshift and saying, gosh, we started out with Postgres and MySQL replicas, and then Redshift came along and we're running at scale. One of the bets I see in Malloy is a bet on DuckDB. So tell me a little bit about DuckDB. Is the opposite of Redshift. It's small and lightweight and embeddable and in process. Maybe explain a little bit why I see so much gravitation in the Malloy.
When I started working in computers, they ran in. I had 640K of memory, right? Okay. My laptop now with DuckDB is faster than the Redshift was then.
Okay. Today, you're saying that
my laptop with DuckDB running on it is faster than a Redshift cluster. So, like, that's why DuckDB is so important. It's like I can link it into my application. I can just I can link it into Malloy in VS Code, and it's faster than Redshift was when we were. So, and it can handle data sets that are it can't handle metascale data sets,
right?
But it can handle data sets that are large for most enterprises. And so, I really feel like, and they've done an amazing job with the SQL dialect. It supports all, and they're great to work with. I've become close to the team, and early on we contracted with them to do Malloy features for us, and they're just great to work with. So I think it's really amazing.
Okay, the topic that a lot of people are here listening to, folks on a Moscone stage somewhere, in the urban jungle a few blocks away, is AI. And so, and you're now part of a company that is obviously making some multi-billion-dollar bets in that space. You're
Right.
part of the data visionaries there. Maybe without going into what Meta's plans for AI are, I would ask, as a longtime practitioner creating some of the tools that many data folks use, how do you believe? I'll actually ask two questions. One is how do you think AI might change the way that data developers and data practitioners work?
Mm-hmm.
And maybe the other version of it is what won't change?
Sure. So I think it's pretty good at doing simple translation. Um, at Looker, I would go around and everybody that started the company, I would teach you how to use Looker. And we had this airlines data set that I've been using since the beginning of time. And I would say, okay, which carrier has the most flights to JFK? And how do you answer that question? And what I was trying to do was teach them to translate that into UI clicks, right? And that's relatively easy to do, right? So that level of question and answering, I think, is relatively easy to do. And we'll get there. Like there's no question. And the semantic model makes that much better, right? Because there are things because you have dimensional freedom. You can pick whatever dimension you want. You can pick whatever measure you want. And the measures are named, right? And so the semantic model makes this super easy to do. And then the filtering part is a little harder because you need to do some kind of inspection into the data set to see what the interesting dimensions are. So yes, anyway, Malloy's really good at this, or could be really good at this. There's a bunch of people who are using Malloy for this, which I'm happy about. I think the harder questions are, I have this data warehouse with all these tables in it. Do something for me with the tables. I think good luck with that.
Right.
Okay. I think that's a pipe dream. I don't think we walk into a data warehouse and there are 10,000 tables and half of them have the same column. Some columns repeat some of the different tables. So, what makes sense out of that? Good luck.
Right. Right. But I think the idea that if we infuse a little bit of semantic modeling on those thousands of tables first,
we can do a lot. Yeah.
Then we can do a lot after that.
Yeah.
What are some of the use cases that maybe emerging use cases that you are most proud of? Again, version of this question would be, what are you most surprised by in what you've seen people adopting Malloy? And what are also the use cases that you're maybe just most proud of, seeing in the wild?
There's a professor in the University in Washington who has been teaching his business students to program in Malloy instead of SQL. They learn basic SQL, they learn Malloy, and and he's saying, like, he's having a really successful class with it, which is like the most important thing for me is it learnable? Is it so like can somebody be productive with this tool? That's what we're working on right now. We've thrown the language. We're on Malloy 4.0 because we've thrown the language away 3 times. Okay, it's hard to figure out how to get it so that people can understand it and operate on it and can build on familiarity. So the fact that it's learnable is the most important and surprising and hopeful thing. And then the semantic modeling thing has always been really exciting too. That there are people who look at it and go, who've been looking at the AI problem, who've been looking at the AI problem for a long time and say, this is the way we should solve this. So
what lessons from you? You said you had a stint as a teacher at one point in your career. What are some of the lessons that you've taken from that experience in education to translate into your role as a entrepreneur? And
teaching middle school shaped Looker's culture clearly. I worked at this great private school in Santa Cruz. They let me in to go work with the kids for free. I wanted to, and so I ran an after school computer club, and there was a woman named Cindy Zimmerman who I loved, who was not that technical, but she was really good with the kids, and she ran a computer club that said you had to make something. You couldn't play something in her computer club. So that was really cool. It was like the kids were all making something. And the rule at the computer club was if somebody asked you a question, you stopped and answered it. because that was just the rule. That was the way that it worked. And you could never make anybody feel bad about asking a question. And if they and that created an amazing learning environment for these kids, and they were doing amazing things that Cindy didn't know how to do, right? And when I was there, they were, the kids would help each other, and then it would eventually get to me, and I didn't know the answer, and where I would, and a lot of those kids learned to program and did all kinds of crazy things. And it turns out that that was in 2000. That was around 2000, and by 2011, when we started Looker, I started hiring some of those kids to work at Looker. It was crazy. It was totally crazy, right? And in fact, the person who started Meta today with Spiros was one of those kids that I've known since kindergarten.
Wow, that's the long game.
That's the long game, right?
Okay,
so whenever you're giving back, when you're doing something, I always thought I was giving back then, and I think that not knowing why you're doing something, but doing it that's helping people is always a great thing to do.
Yeah. Well, great story. For anyone who's thinking about making their hiring pipeline a little healthier, this is your chance to go start an after school computer club, and you'll have amazing candidates. Just wait 17 years. One of the questions that I wanted to ask you, based on our first call a few weeks ago, I know that a lot of folks are out there trying to build what has been variously called the metrics layer, the semantic layer, and maybe you're such a positive guy, so I'm sure you'll find a positive way to state it. But what you said when we were hanging out earlier was, I think a lot of people underestimate just how hard it is to get it right, and so especially in technology, a lot of young technologists will come in and rediscover things. What are some of the things that you feel, as now in your 4th version of Malloy and your 8th version of tools that help people look and understand and interface with data, what are some of the things that you feel like you're getting right this time, but that maybe you got wrong before, and that others may also be not getting right? What are you getting right this time?
Okay, so the core of getting the one is that it's a developer tool. It's a programming language. You have to treat the program. You have to treat data people like developers. So that's first and foremost. And we got that right in Looker, and I think that some of the other layers have not gotten that right. You need to build the tooling around the language in order to, yet another language without a debugger was a thing that I had heard, and it's making sure that the development experience is fast, and the cycle. You're thinking about what the cycle is for the data developers, so that they can be productive in your world. And so that's it's the first thing to get right, and it's why Malloy runs as a VS Code extension today, and it's where it lives, right? And we keep trying to make that better. The other thing in the semantic layer is, if you're just dealing with a rectangle, you're not going to add enough value. Okay, so the hard part is, everybody knows how to work in a rectangle in data. It's group by, aggregate. We learned this in kindergarten.
Even your after-school kids knew that.
Right. It's the first thing you learn. It's how many coins are in the pile. Let's set them right into coins, to dimes, nickels, and pennies. Filter out the pennies. Okay, now how much is each pile worth? That's aggregation. That's all we ever do with data, it turns out, right? But the hard thing is that when we start joining in data, everything gets really complicated, right? And so all of the tools try to solve this problem differently. You materialize tables as one solution, and then join the materialized tables. But the thing that Looker solved that no one had solved before was that join aggregations don't affect join relationships don't affect aggregate calculations, and so that gives you the ability to just pick a dimension from anywhere in this graph, right? And pick a measure from anywhere in the graph, and it will produce the correct result, right? And that was an innovation. And you can pick as many of the dimensions as you want, as many of the measures you want. It's always going to do the right thing, and it's always going to produce a good rectangle. The thing that we learned in what I learned from Malloy is that data doesn't exist. Data exists in a graph, right? and SQL models it in a flat space, right? You've joined it into a matrix and you've lost the graph. And so Malloy doesn't lose the graph. You join the graph, you got the graph. Okay. And now it turns out that you also don't want to produce a table. You want to produce a graph. And so Malloy also produces the graph as output. And that is the thing we learned that I think is the way we understand data is we dimensionalize by something, we measure something and filter. Those are our tools that we have. And putting it in a graph lets you do all of that. You do a lot of that simultaneously.
But in the way that tools influence each other, tools influence databases, and databases influence data collection and ETL. Is it? And I think I saw you write or speak about this, that if we think about the most common form of data these days are JSON events, right? But all of the ETL tools out there, all of the ingestion architectures and pipelines essentially flatten those JSON events out and put them into a bunch of rectangles. And now Malloy comes along and says, "Oh, okay, people write joins," and then we kind of you figure out the network graph and maintain it. But wouldn't it be better
just to leave it in the graph?
Just to leave it in its original form instead of kind of pulling all these rectangles out, flattening them, and then having to manage this. And is that
yeah, that's it. So BigQuery did this well, right? I mean, they originally BigQuery didn't have joins. They just pulled in protobufs into and wrote them out in a column store, and then they could query them with their language. And it took them years to figure out how to get the SQL right so that you could do this
right.
Right. I mean, it's not an easy problem, and it turns out that unnesting these structures is the way that you want to do it, or you want to be able to do correlated subqueries into the array. They got it right, and again, this is like one of those advanced SQL things. It's like you can do this in all the other dialects, but it's very difficult in Snowflake. It's difficult, but it's the way that you want to be able to take the data and run these column stores against the data without moving it or transforming it.
Right. One last question, and I'm going to open it up to the audience for some questions. I want to be thoughtful while the sun goes down. I'm envious of all the folks who've got the sunny spots here. Well, Lloyd and I, this is Santa Cruz. We're bringing the Santa Cruz weather to the city tonight. We saw last week an announcement that this company, Tabular Data, not to be confused with CSV Data, a much more valuable business that will be bought for $10 billion next week. With Tabular Data, the folks behind the Iceberg project acquired for over $1 billion. It was rumored by Databricks. And I think in general, we're seeing this shift towards object storage. And DuckDB, in some ways, represents the ability to not even have to run, that Redshift cluster you're running in your laptop, doesn't even run. It's almost an ephemeral Redshift. So I guess I would just ask, what are you seeing in terms of Malloy and its relationship with sort of the shifting landscape of the layers below Malloy, namely object stores, and whether Parquet files will end up being, the future of data storage rather than cloud data warehouses?
Yeah, the separation of compute and storage is actually really interesting, right? And BigQuery did that a long time ago. It allows you to take large compute clusters and point that at data wherever it happens to be sitting, and data where it's sitting can be in different formats. And I think we're there actually. One thing we haven't talked about, which is data privacy.
Yeah.
So privacy and access control is tough. So while data can move around to all these places, you also have to secure data in all these places. Mm-hmm. So again, it's going to be bespoke. I don't think it's going to be one size fits all. I think that you're going to have data that you absolutely need to have in the warehouse that is secured in a way that has very tight access controls and who can see it. And then I think you're going to have other data that isn't as important to be secure that may flow around in a different way. So,
and I think a tool like Malloy, meaning that you can bring Malloy to any of those data environments in a safe and secure way. Right. You're not requiring them to.
The footprint of Malloy is designed so that one Malloy query is always one SQL query. So the goal here is that it can sit anywhere that SQL sits,
Mm-hmm.
right? And even in a DDL, like it can sit as part of the DDL statement. And so instead of having to write the select statement, you write the Malloy statement there, but you write it more efficiently. And so we're hoping to be everywhere. That's our goal. That's our design point. I don't know that we'll get there, but we're going to try. And if we don't get there, I hope that the ideas live on.